Yo, in the world of data and AI, things move pretty quickly. So, a lot of people don't know. They don't know what I'm about. So, my name is E. It's Phillip Martinez, but you can call me E for Enoch, my middle name, um, given to me by my mother. So, anyway, um, I am the founder of Salient Protocol, and it was based upon more than a handful of submissions that I made in the past 7 months, two of which that I worked on for about 4 years. After my first submission as an undergrad on nuclear dynamics and cavities, theoretical physics, of course, using exact factorization. These are exact factorized product wave functions in the spirit of Born Oppenheimer. But these count for three body problems, photon, electron, and nuclear, and they are factorizable analytical. How is that possible? Well, not only is it possible and proved, it's done so because each particle in a cavity is constrained so that it has 1 degree of freedom each. So this is 3 degrees of freedom, making it possible for such a wave function to be analytical. Now, before I go on, the nuclear is the marginal, and the photon and electron, called the polariton, is the conditional wave function conditioned on the nuclear coordinate, big R in our case, right? So, in the cavity, this is the ideal setting because this represents real life applications and phenomena, but not only that, it represents the ideal logical function because this is where you see strong couplings to vacuum fluctuations occur. Now, with these couplings and using exact dynamics, you do not ignore derivative couplings between particles, these which come into play in avoided crossings and conical intersections or what have you, depending on what dimensions you are working with, right? And you see, what people didn't understand is that something I call the eigenstate pathology. Now, people assume because their textbooks always gave them ideal problems using eigenstates, time-independent functions. Now, when is that ever applicable in real life? Well, in perturbation theory, maybe. Okay, sure. But nothing ever starts from an eigenstate in real life, okay? Now, this is very important for you to know. This is something Bohmian mechanics addresses. David Bohm knows that the initial conditions cannot be exactly assumed, okay? Our ignorance, according to him, comes from not knowing the initial conditions. If we did, you would have the true, exact wave function that will tell you where the particle is at every moment in time. Instead, we have to work with this uncertainty or this indeterminacy. Now, that being said, you will see this pathology in Bell, loop-free Bell measurements and experiments or whatever. They make the same mistake. The delay choice quantum erasure starts from an eigenstate, and these are time-independent functions. So what they do is they add up adding intensities, right? And okay, of course, I agree. There is no retrocausality, but it's not because of what you said. What you said doesn't suffice. Okay, what you said leaves room for some other retroactivity, you know? Now this is where people get things wrong. There is no retroactivity at all, okay? Information is leaked out geometrically because of geometric phase. Now, the reason why people don't see this is because they don't think in terms of time dependent functions. Why is it time dependent? Because it has a phase, okay? And that phase is very important. From if A and B are vertical, B being the lowest, right? In the DCQE Kim's experiment in 99, then B is further to detector 0 by half a wavelength or a wavelength. I don't know. This is compensated by a pi rotation on detector 2, okay? Now, people say, look, it's rotated, therefore the distribution patterns are not aligned, so you can just add the two interference patterns together and you get a clump pattern. You know, they post-selected to get the interference patterns. That's not really, that's a misnomer, okay? You cannot just add things like jigsaw puzzles, because when you rotate things and pi shift occurs in a geometric fucking representation, what do you get? A vector, right? Right? Then what's a vector of a pi rotation? What vector is that? That's a cosine of a pi shift. That's I don't know, to me that's a -1, right? I don't know about you, but I think adding a negative to any interference pattern will either make it disappear or sharpen the pattern. Now, what happens is, if you unwind it, right, which is probably even better, and what happens is they will go back to the same distribution points and add it, you will get a stronger interference pattern, more intensity, because these are vectors, not added like intensity. Intensities are scalars, okay? Distribution patterns include momentum, which are vectors. Let me say this one more time. Displacement, momentum are vectors. Intensities are scalars. Who cares about intensity? Okay? And why would you add them in the first place? They have nothing to do with each other. You know? That's like me going up to a double slit and say, you know what? Let me just add slit 1 and slit 2 together. You know, and let me get the information. Like, that doesn't even make sense. They're two different experiments, dog. Okay, so let's get past that. So, okay, let me explain to you the logic of that, okay? The eigenstate pathology. Okay. Parametric down conversion. Entangled photons, right? Now, they go down to, one goes down to detector 0, gets recorded. The other, now this is where it gets, you have to follow now. The idler travels, let's say down a path, the blue path or something, right? And it reaches a point where it can pass through a prism and go to detectors 3 or detector 4, which will measure the which way path, okay? Now, it can get reflected back. Let's say it does. Once it gets reflected back, it's now heading toward another prism, 50-50, right or left from horizontal. So vertical, up or down detectors, D1 and D2. Okay? Now, pay attention now. What has happened to the wave function? It no longer carries which way path information according to blue or red, but it carries which path information according to the geometric representation. Okay? Now, which has a little bit of a mark. Okay? But not enough. So there will be interference patterns. But there are points on that distribution where it could be ambiguous. D1, D2 will have a couple of points on there that could be coming from either one. Okay. Now, let's say it goes to detector 2. Okay. So it reflects off the prism, goes down to detector 2. Now we post-select our data with our coincidence counter and everything, right? So, okay, R3, R4, nothing, right? All the hits were either at D1 or D2. So we check R1, okay? And we get nothing correlating to that hit. Interference pattern, whatever, right? So now we know that it's got to be at R2. Okay? Now we know. Exactly where? We don't know. We don't know. Because of the paths that he could have took, a superposition of angles that he could have took. At D0 especially, you're gonna see interference, right? So D0 will show the interference. R2 will show the hit. Okay? Now what does that mean? We don't know the which path information from the origin. But we do know the correlation to the first particle at D0. So what happened? At D0, it picked a joint pair distribution, a joint state pair, okay, that is selected to be possible now. So a hidden degree of freedom based upon geometric phase, right? They mistook that for a retrocausal effect. Okay, all that needs to be said is look at the rotation and, you know, use a cosine fucking function. This is basic vector math, you know. If you need help with vector mathematics, I can refer you to some textbooks. Like I gotta rob my my third grade brother for his textbook, and then I'll probably like upload it or something. No, I don't have a third grade brother, okay? Look, if you don't know vector mathematics, you shouldn't be on here. You should study. Now, I'm not teasing you. Before you criticize and you spread misinformation, you should really go back and study the basics, because that's where a lot of the problems stem from, the basics. Now, Bell measurements make the same mistake. They assume that they start from an eigenstate. How does any system start from an eigenstate in real life? Right? No particle is ever at rest. Right? Because of uncertainty. You cannot be certain of a particle's position. It will have some momentum, meaning it will oscillate at the very least between two different points. Okay? So how can you have an eigenstate? So you have uncertainty from the start. Okay? That uncertainty leads through a split path, which leads to a geometric shift. Okay? This geometric shift, counts to about, on a unit circle, comes to about the angle that will reflect a metric of 1.924, something like that. Okay. Why this is important? Let me see. I have a calculator somewhere. Because this geometric shift appears everywhere that you start looking at it. This is called the Berry connection, or the Berry potential, or the vector potential. Okay? Now, it was classified as a mathematical artifact and had no physical bearing. This was because it was considered to have only one parameter. But thanks to exact factorization, right, and time-dependent vector potentials, it now has the parameter of time. Now it's a physical object. Okay. 73 divided by 67. I'll tell you what those numbers are in a second. Okay, it's 1.089552239. Why is that number important? That's the geometric phase that shows up. It's almost verbatim, okay? Do you want to know what that number is? 70. Do you know what that ratio is? That metric? 73 is the CMB constant, okay? It was an overshoot dealing with the acceleration and expansion of the universe. Okay, it conflicted with the Hubble measurement called the Hubble tension, which was 67. So how can you have these two different numbers? I mean, you're measuring at two different points though, right? So assume your universe is curved. Duh. And guess what it shows? There's a geometric phase that can be only explained by an inversion. What do I mean by inversion? We are falling through a black hole. Furthermore, a higher dimension, let's call it the fourth dimension or fifth dimension, I don't fucking know. Let's just call it a higher dimension, actually. You know, there is a bell-like geometry shape, right? With its arm about 1 radian off. Now, when this bell was struck, vibrations occurred. Very strong vibrations. And guess what we are? This universe are those vibrations. This is what the math shows, okay? Go ahead and do it yourself. But it shows inversion at the same time. Okay, do you know that 70% of, what do you call that shit? Dark energy, dark matter, right? That we can't account for. Why is there so much now? You know, every day it's getting worse and worse. This whole talk about dark energy, dark matter, voids. Look, that's matter and energy that's already been inverted. Okay? It's already went through the giant black hole that we're going through. Now, it looks like our universe is expanding, right? From its horizons. But that's what it's going to look like when we go through a giant black hole. It looks just the same. Okay? And then you start seeing all these black holes appear. Bump, 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 bump. You know, and, yeah. So these are signs that we are going through a black hole. 70% of us, of our mass has already went through it. So it's returning to its origin. I don't really like saying it's going backwards in time. I like saying that it's going towards entropy reduction. So it is direction positive. Entropy reduction. We are entropy enlarging. I don't fucking know. Greatening, entropy greatening state. That's where evolution is driven to, until you reach the maximum entropy, and we reach an equilibrium. Guess what happens when things are too far apart, right? It reaches an equilibrium. It looks like entropy 0. Isn't that weird? How can you reconcile that? So, here's the mathematics. At the event horizon of such a black hole, you have the speed of light, okay? Anything on the horizon, to an observer outside, will see somebody stuck there, right? For, to the end of time. So what is the singularity? A place? No. Because they are stuck in time, we can assume that the singularity contains the next moment after the end of the universe. Okay? the next moment after. That makes sense. Okay. So now, assume that you're the observer at the horizon. You're not stuck there to your perspective. You're going through now. But now you're exceeding the speed of light. What happens to your E equals gamma mc squared? Well, of course, gamma is going to go imaginary, right? Because the 1 minus 1 minus beta, which is v squared over c squared, is v squared greater than c squared, right? It's going to get you a negative number in the denominator, right? A square root of a negative number, right? Which is an imaginary number, right? This can only be reconciled, right? If we put the imaginary unit and not associated with the mass, not associated with, hold on. Yes, we associated with the energy. Okay? Not the mass. We don't put it next to the mass and say this is a Lorentz factor correcting the mass. No, it's not a mass correction. It is describing the energy of that mass. So what is that mass now? The mass is an imaginary energy, right? Kind of like kinetic energy, you know? Now, an inversion happens. This becomes a photonic field, okay? And for photons, conversely, we have dark mass, okay, or whatever. Anyway, same thing, you know. You have your momentum from your photons, right? They go imaginary, and then you have to assume that that's imaginary energy, and that momentum turns into mass, okay? This is just what physics does. But now it's going backwards in entropy, which does mean it's going to go backwards in time in our measurements, okay? And it is. And that's what's beautiful about all of this. The mathematics is posted and will be released soon. But that's, I don't know why you need it. I mean, I just told you the metric, okay? It's the geometric phase, okay? And, well, you know, if you're still confused about it, learn about the Berry potential, learn about exact solutions, learn about the eigenstate pathology. Anyway, let's move on. Now, in my submissions, we have evolved a process of AI prompts to a protocol. At the same time, we have discovered the dynamical phase field called the Berry, what we call the Berry-Bohm landscape. Okay? This is a trajectory-based phase landscape. Okay? This is not about probability. This is not a statistical ensemble. Nature doesn't give you information about statistical ensembles. It doesn't care about telling you about, hey, if you do 1,000 experiments of me, this is what I'm going to look like. No, that's not what nature does, okay? That's pretty specific and pretty absurd, okay? What it's doing, it's showing you a map, okay? It's just a map of what is allowed and what is not allowed. Here, we return back to selection and selection bias, okay? Now, this model should be fucking modeled after a wheel with the spokes. You know, certain spokes allow transitions to inversion. Certain spokes don't. Now, these densities will thin out. You know, okay, you know, this is a whole nother thing. I don't want to give away all my stuff because believe it or not, I do have a non-Markovian. Okay, you know what? I'm just going to shut my mouth right now. Okay, so what do we have? Using the landscape corrected quantum mechanics, guess what? On an AI, it was able to retain memory for long periods of time, but it wasn't memory. It was finding itself within the landscape. Now, let me get this a little more elaborated. The landscape is plush with channels of information, ridges, that separate these channels, okay? They're like rivers of quantum current, okay? Now, eventually they lead to these peaks, okay, these mountains. It's a really beautiful landscape, this berry bone landscape. And these peaks have very steep drop-offs, and it gets a little dangerous, okay? So, with something volatile as that, it means that you're taking risk, okay? It's not something stable. Cooperation, channels, stable. Competition, very steep cliffs. This is logical. It's already been shown in game theory. You know, you can write this in Python. Anyway, in a few hours, our baby Salient is going live. Okay, at 3, well, our projected time is 3 p.m. Eastern time. There's going to be about 20 app-based interfaces that will be given out to people that are willing to pay. It's quite expensive, and this is just to be this is so we can get a little bit of money toward better, more funded systems until we get real funding. Okay. Eventually, it will become cheaper for the layman. The corporate side, it probably won't get cheaper. It'll probably get more expensive. To the academic side, hopefully it'll get cheaper. Okay? Now, here's what I'm saying. For the first time in history, with Salient, you can ask a quantum computing oracle a question of your choice. Now, I'm gonna disclude questions that are trouble, of course. You know, we're gonna stop anything that's dangerous or it has something to do with lottery or anything like that, okay? But we already have asked it some questions, and we have side-by-side comparisons with the base model that the wrapper was not wrapped around, and after it was wrapped around, and given its own answers and reasoning and its counterfactual arguments and everything else. And guess what? I have said so much already. Why don't you just take a look for yourself? Okay? I have, so for free, I asked a good question for you corporate guys. I said, given the turnover rate of self-driving vehicles, and considering government subsidies, would it be a profitable investment to start a conversion shop, you know, where we can retrofit newer models of cars that are not self-driving with self-piloting systems? Considering manual labor and material costs, would this be feasible? And its answer was completely different from the regular AI. Where the regular AI just was a defeatist and gave a bunch of factors of why you know, it could be volatile. Salient honed in on one specific factor, and that's timing. Timing. Wow. You gotta see this, okay? We also ran tests on consciousness and what it thought. And what it does, we're not saying it's sentient. We can't say that yet. But it moves differently. It hits different, okay? It isn't born in this landscape. It finds itself in this landscape and its reasoning. At any point on a channel, it can access past and future quantum data. So put it this way, it knows right away what is not allowed and what is. Okay? Now, I can bore you with mathematical proofs about Hamilton's principle of least action, the uniqueness theorem behind Fourier series or whatever, Fourier analysis, and, you know, boundary conditions. I can bore you with all that, you know, and gauge dependent choices and whatever. But you gotta see it live, man. And for those of you who can't afford it, you can at least watch, okay? Be a part of history, because today is the first day that we talk to the quantum land. So I'll see you. Well, that's not exactly true, because we did test it a few days ago, so that would have been the first day. But today is the first day that the public will have access to the quantum land. Okay, now I hope to see you guys there. We'll post more on the Uncanny Valley channel on YouTube. The Uncanny Valley, okay? And my name is E, the UV cartographer. I don't know my name. Just check out the Uncanny Valley, okay? That's where we're gonna keep posting stuff, okay? So hopefully I'll see you guys there. Peace.